Yeah, I'm Dag Sneeggen. I work for Signicat, and I'll be talking about, it's a bit of a title, Navigating Cloud Native Security and Emerging Patterns in Workload Trust. And that's going to be our talk about workload identity and how that can be, I guess, leveraged in APIs. Clicker works, perfect. And the sort of central question I want to focus on is how can you trust the software? How can you know that the software is what you think it is and it hasn't been replaced or messed with in any way? And it's more complicated now than it ever was, and I'll get back to that, but zero trust architecture and also like MCP and agents and non-human identity, that's been like a big driver of the complexity. So it's really critical that people focus on this now. Adam had a great talk yesterday which covered this much better than I can cover it, but I just want to cover the history on terms of the security, not on the APIs themselves, but just the API security. And as Adam was saying yesterday, the idea that started APIs, there were public APIs, and they use something called API keys, which are just static strings, like a password for APIs. And in hindsight, I think we've realized that those are terrible because they are static and there is no control. And in the 2010s, they started OAuth 1 and OAuth 2, which was great, and they are still great. But I think in the last 5, 6, 7 years, there's been an advancement in the sort of standardization and extensions on OAuth especially. I'll list some of them there, but there are more. Earlier this year, I was at a talk with Mike Jones, one of the authors of OAuth 2, just an amazing guy, and he had a talk that was called The Cambrian Explosion of OAuth and OpenID Specification. And I thought that was a very good term for it. But these standards can help us today. They are very useful, and they do give you a much better control of your security. So we come to static secrets. As I was saying, the API keys, they are terrible, but you still find them. There's a lot of APIs today that you can use, even from Google and things, and Apple. They have API keys as the default. But the most common thing that's happening now, I think we're all aware, is the client credential flow, the simple exchange of a client secret, client ID for a token. It works, it's fine, it's very effective. But it has a problem in that the client secrets are usually quite static and quite long-lived. And they need to be managed, basically. I'll come back to that in a moment. I just want to make sure that we all understand these concepts of cloud native. Typically means something running in Kubernetes. It means AWS or Azure or Google Cloud or any of the other clouds, like even Scaleway are doing public clouds now. So everyone is trying to get into that market, but the big three, they are dominating. Zero trust, I think it was mentioned, I don't remember who, but someone was speaking today and they mentioned NIST standards. There's like 3 or 4 NIST standards related to zero trust architecture that are very, very good documents. But it means that internal services should be treated as public services. So your internal APIs, they should be treated like public, and you should authenticate and authorize them in the same way as your public APIs. Which is a very good concept, of course. The zero trust architecture is popular for many reasons, but it creates complications because you have a lot more APIs and a lot more access points. And something that has been very, very apparent in recent years, and there's a lot of focus on this now, is something that's termed secret sprawl. And I say it here very specifically that actually when you have a modern cloud native platform, it'll evolve over time and you will experience secret sprawl. It's not a question if you could, but I think that you will eventually experience this problem. Because your organization grows, it has many teams, many development teams, many other teams, many solutions, and because of the whole cloud thing, your solution probably has a lot of services, microservices, different things. Can even be things like cron jobs and things that are running out of band. And with AI, you could also have a lot of AI models and agents spinning up and spinning down. So it's very uncontrollable. And each of those solutions, they can have many OAuth clients with many secrets. So it's not uncommon for big organizations to have thousands and thousands of secrets. And every single one of them has to be securely managed. You have to store them securely, you have to access them securely, you have to rotate your secrets. And I think there's been some recent security incidents, major ones, where there's been like orphaned secrets, clients and secrets that nobody knew about because they were just lost by some development team that didn't exist anymore. And then it gets leaked, someone finds it, and it has a bunch of access because nobody remembered that it existed. So this is a major issue, and the rise of workload identity is probably driven in large by this. It was started by Google. I'm not going to read all the details here, but essentially it's 2017. Google started a SPIFFE project. SPIFFE was a way to formalize the concept of workload identity, which means that a software gets a cryptographic identity that is portrayed as a document, a cryptographic document. It can either be a JWT or it can be an X509 certificate. And that document has something called a SPIFFE ID, which is a unique ID constructed for your workload. In specifically the example I use with Istio, it has your namespace and service account, and you can have some other details in that as well to uniquely identify the workloads. And why does it matter? Because it solves something very important, and it does it in a way where it's platform managed and automated. And it solved the idea of this bottom turtle problem, where you need an initial secret or credential or something to bootstrap, but that's created automatically here by the platform and given in a secure way. Yeah, and there's the portable passport, which is the ID document, and WIMSE working group. I think it was mentioned yesterday as well. It's a very good initiative that started last year, where they are trying to make this into a more sort of general workload identity architecture with more standardization. Now in Signicat, we had some issues with secret sprawl and other things that caused us to build a system for workload identity. And it's actually running in production. It's serving millions of tokens. And the key finding that is a novel idea is that we leverage Istio, because Istio and all the service meshes, not just Istio, but all of them, when there is internal communication, they establish MTLS between it. And they use a certificate that is kind of SPIFFE compatible, because it has a SPIFFE ID. So we leverage that to give us the workload identity. I see that I was working on a presentation to make it a little bit better, but this is the older version of it, unfortunately. I didn't get the updated version. But This is an illustration that shows it, how it works. There shouldn't be that thing in the middle. I tried to remove that, but it's still there. But I can do it without it. So what happens is that the service, let's go again. I can't replay it now. Okay, it doesn't matter. The service needs an identity, which it gets from Istio when it starts up, basically. Istio issues the certificate for it. And then when the service is communicating, so here it should be an authorization server, it shouldn't be this icon. When the service communicates with the authentication AS to get a token, the certificate is sent on the request, and the AS picks that up, and that is used as the authentication of the service. And then a token is issued that has information about the certificate. So the token is bound to the certificate. And then the service gets it and talks to the other service. We have an IAM solution that can validate the token and check the permissions that's given to the service. And it also does a workload binding. And that means that it checks the information in the token to make sure that the right service used the right token. So if someone steals the token, it doesn't work anymore. Let's skip forward. So this is the sort of central statement that I have, is that most people, if they are using client credentials for like inter-service communication, you are not authenticating the right thing, because you only know that something has access to the client ID and client secrets. You don't really know what it is, you just know that something has that access. But here it solves it. SPIRE, SPIFFE solves it, but we solved it via Istio, as I mentioned. But you're strongly linking the identity because you have the workload identity certificates. And that is not really forgeable. It's secure, and it's not possible for another service to get that access. Sorry, I'm a little bit confused because it's not the right version of the slides, but we'll work around it. Then there's another problem in that you can authenticate your workload, and you can say, so is that fine then if they just pass their workload certificates on every request and you're sort of done and you don't need anything else? But you actually need like an authorization context. You need information for every request about what is being accessed and why. So you need a token. And I think mostly for sort of backwards compatibility, we went with the access token, just normal access token, in our solution at least. But the difference is that we leverage this RFC 8705, which is one of the more recently developed extensions to OAuth. The idea of this specification is that you can actually use MTLS as the client authentication, because I think some people are not aware that the credentials, client credential flow, it doesn't have to use client ID and client secrets. That's the default client authentication. But there is like private key JWT, and there's a couple of other ones. And this one says that you can use MTLS certificates, which is very convenient because that's what we get from Istio. So we use the certificate that Istio provides, and we check the workload binding, and we issue a token that is bound to the workload. The illustration was supposed to show that, but that obviously didn't work. But it has the token has a CNF claim, and that is checked when your PEP or PDP checks your token, you can check also that the right certificate was used together with the token, so that only the service who has the certificate can actually use your tokens. Am I? Yeah, okay, on time. I think this one we have to skip for time, but we have a sort of cool automation where the namespace and service accounts, where they are actually created, they also get like a client. But we don't need to get too much into that now, I think. So our approach, it gives us platform manage identity, and it doesn't require a lot of work. And it's quite secure in that if you trust Kubernetes and Istio, and if you're in the cloud, you kind of have to trust Kubernetes and Istio anyway. Of course, if that's broken, then there is a lot of issues that they can do if they break Kubernetes or Istio, so we're kind of consolidating the trust a little bit. But it means that it's completely transparent for the actual service, because when the service A is calling service A, calling service B, they don't know the fact that Istio gonna intercept and put on a certificate. So from the service, it just looks like they are calling without any authentication, but the platform is sort of handling the authentication for them. And it handles the whole thing. So just to sort of summarize, the workload identity gives you a solid foundation to authenticate your workloads. Whether you can define your workloads a little bit different, you can have like a whole solution with several microservices, or you can have just a single, even like a pod or process can be a workload. That's kind of like depending on your business. But it definitely gives you a much stronger authentication. And also you can bind your tokens to it, which gives you protection against these attacks that are happening now, where people steal tokens and they use them. It's very common, unfortunately. And I wanted to look a little bit into the future as well. There is a very interesting work in an IETF OAuth working group now on something called transaction tokens. And those are supposed to be sort of single-use tokens that lives for a very short time, and they should only live for like a single transaction. And they specify the intent. So it could be this token is for this specific API to call this endpoint and do a financial transaction. Or it could be a little bit more general, that there is a financial transaction of this amount that will call several APIs. An OpenID Foundation has recently published something called CAEP and SSF, Shared Signal Framework and Continuous Access Evaluation Protocol, I think that's one is. It's all about like risk-based control, where you could potentially deny a request because there is a new risk coming, or there's a problem with one service, and you can sort of flag it for denying it, basically. And probably because of the whole agentic AI MCP, there might be like developments on more like sort of onboarding, where you have to look at a lot of data, which SPIFFE actually supports this, where you can do, like you can say we only allow certain models, or this AI is supposed to be doing like financial transactions, so if it tries to do something else, it shouldn't be allowed. Yeah, and I'm almost out of, well, I'm out of time, but I'm also finished. Skit bomb, yes. That's me. There's a blog post on this swim pattern as well feel free to check that out and also reach me here or on LinkedIn.